Everyone, glad to share our work, investigate the access or permission request in Trigger Action integrations. I'm Liu Huo, and currently I'm the third year PG student in UQ. What's the definition of Trigger Action integrations? The famous examples include the FTTT, Zephyr, or SmartThings. It can help services connect with each other and form some simple but useful automations. We take the FTTT as an example. It has over 20 million users and supports near 700 third-party services. Here are some several examples. So when the new email arrived, the TIE can help you to upload the attachment to OneDrive Cloud. Or when the sunshine times, the TIE can help you to lock or unlock your smart doors. And every time there is an online payment happens, please help me to record this transaction. So these simple rules help the users to connect different services with each other and form some simple automations. But this also brings security and privacy issues since the TIE have the permission to access any sensitive information, including your Gmail body attachment, your online transaction, or your Google spreadsheet data. But also it can perform arbitrary actions like delete your files on the OneDrive Cloud or even unlock and lock your smart doors. As we previously mentioned, in order to perform actions on behalf of users and access the user's resource, the TIE must gain authorization from users. So every time the TIE want to perform actions, they must gain authorization from users. And after the approval from users, the TIE, here is the IFTTT, can use this access token to perform arbitrary actions without users' approval again and again. And here, the left side represents the APIs that exposed for TIE by the service MyDrive. So TIE can use these APIs to query the new files in this folder, the history of files in this folder, and even perform the upload file to specific folder from the URL. So in order to perform these arbitrary actions, the TIE need to gain authorization or permission from users. The FTTT will be able to see your photos and videos. But if we take a closer look, we can see that there is one permission called delete your photos. Is there any such API called MyDrive delete photo in the left hand? No, so this is absolutely an overprivileged permission. And that's our goal, our work's goal. What's the functionality and permission and functionality consistency? Does the TIE or FTTT actually request the correct permission corresponding to its functionality? So the functionality here refers to the API that can access TIE's resource and perform arbitrary actions, while the permission refers to the request or some permission from TIE and provided by the service provider. And the consistency is that TIE should not request unnecessary permission beyond its functionality. We have identified 3 challenges, and the first challenge is that, as we previously discussed, because the diversity nature of the TIE, it including the smart home, your online storage, and other services. So the documentation of the request permission is usually written by different service providers in various style and quality. In order to handle this challenge, we extract a unified representation, which is the operation on which object from the diverse description, using the large language model ChatGPT, because it already shows excellent performance in such tasks, and it has a very excellent ability to capture the semantic meanings in the natural language, not only in the word level, delete your file in the word level, but also in the word phrase level, like turn on or turn off your devices. Another challenge is that similar to other systems, like if you are familiar with Android or Windows system or Unix system, there are some permission hierarchies. So here is one example. In one online editor service, there contains the permission orders. So workspace are in here order compared with board or compared with list and compared with card. If we didn't take this permission hierarchy into consideration, Using the large language model, we may consider the bold and the card as semantic similar, and they may refer to the similar or actually the same operation. But the actual case is that bold are in higher order compared with card, so we cannot mix them together. And to handle this challenge, we utilize a series of NLP techniques to help us construct the latent system and resolve the hierarchy in the previously built operation and object pairs. And for the last challenge is that, as we previously, we only have the accessible to the exposed APIs. We cannot get the source code like other system. So we use all the metadata of the API, including its description, its metadata, like its parameter, its return value, as the functionality indicators. And we extract the request permission based on automation, service, or authentication tools. So what's our approach? We will call it the PFCon, as its name suggested, the permission, functionality, consistency detector. And it's a systematic approach to check the permission request by type and its actual functionality. Besides, the PFCon try to understand the overprivileged issue, which is the request, excessive permission request in the real-world type services. So our approach can be divided into 3 phases. The first phase, we will try to extract all available artifacts, including the functionality and the awesome permission, which is the request permission. In the phase 2, we will get the unified permission extraction, and in the phase 3, we will get the latent system construction and do the consistency checking. So for the phase 1, we will extract the functionality artifact from the homepage of IITT. It's provided by the type. And for the permission extraction, we need to automatically log into the service provider. So we create a list of task count, like the Gmail service, the OneDrive service, or Smart service. We use some keyword like username, your Gmail address as the identification for the login field. Then we automatically identify this login field and log into the service and call the permission request after we successfully log in. For the unifier pair extraction, we can see this rectangular represent our for sentence, and our for sentence may compose a series of permission. Previously, we say FTT, we're about to say, delete, or edit your photo and documents. It's a series of permission. We do it in a 2-step way. First, we separate this complex sentence into some simple sentence. Then we extract the operation and object pairs from this simple sentence. After we have extracted the unified representation, we need to construct the latent system. So here is the extract pair, and we want to reserve its hierarchy, which is a permission system. But we know that operation and object is actually a 2-dimension pair. So how we construct the order for 2-dimension pair? So we do it step by step. We first construct latents for object level. Then based on this object, we do construct the latent system for all the operation on this object. And then doing this, we can build the latent system for these 2-dimensional pairs. After we have successfully built the latent system, we can do the excessive permission checking. So the left hand represents the latent system for the request permission, while the right hand represents the latent system for the functionality. We can see this purple circle represents an excessive permission in object. And after we have done the object excessive permission checking, we will do the operation levels. Similar for these 3 circles, you can see that it's an excessive operation. We apply our tool in the real-world type, which is IFTT. It achieved a very good performance with nearly 100 true positive rate and 94 true negative rate. Our service reveals that around 1/3 service will be requested with excessive permissions. This includes but not limited to the smart home, your online banking, and cloud storage. So if we have a close look for the online editor, you can see that the most popular request permission are the remove or delete. When this operation are manipulated, you can cause severe impact for users' data because the user will lose their data. But this is an excessive permission. We also investigate the root cause for the inconsistency, and it can be divided into three categories. The first is permission bundle. We found that the service provider may group different operations like add, delete, or edit into one group and exposed for the type to use. Similarly, if the service provider provides access to photo, video, and text fields, they will group them all and expose to type to use. Oh, sorry. The second one is template usage. For the different service belongs to the same company like Google Doc, Google Slide, or Google Spreadsheet. They may use the one template with only changing the service name. So this means that the service which will not fit in this template will be requested with excessive permission. And the third one is that the permission system actually has some design flaws. Some service will use the coarse-grained permission, like control or manage your device, compared with more fine-grained permission, turn on or turn off your device. Others is that developer just expose all the permissions to the time. We found that for one online banking service, it provides freeze and unfreeze your card. It's quite dangerous and it's not required at all for the type to use. When this permission is manipulated, it will cause severe loss to users' financial money. We found that this cross-service platform do bring convenience for the end user because it can form some simple automations and connect different services, but also some overprivileged permissions are requested. And we investigate into the actual type and find many violations that may cause severe impact. Our work can be used as a detection tool for both the type and end users. Besides, we encourage the service provider and type should work together to enhance their security. So I'm ready to answer your question. Thank you.